Okay class, we're gonna start to learn a new chapter today, which is polynomials. So without further ado, let's start our lesson now. Okay, that's all for our lesson today. I hope you guys understand this chapter very well, since this topic gonna be related to another topic that you will learn in the future. Remember that knowing the theory is not enough. You need to apply on your daily life to understand more what you've been learning. That's all. Goodbye.
Thank you, madam.
Thank you, madam.
Okay, but thank you, madam.
Okay. Thank you, madam.
Thank you, madam. This chapter kinda easy. This carpet seems like it's too big for my room. So, however, there still have some parts that are not covered with the carpet. So this is make me wants to know the dimension of the carpet. The rectangular carpet is twice as long as it's wide. So the part not be covered is a constant too, and has a large of area is 196 square feet. So let's assume that the first polynomial as 2x plus 4 times with x plus 4, and the second equation is 2x times x is equal to 10. If we subtract the first equation and the second equation, we will get the area left, which is 196. So the solution is 2x plus 4 times with x plus 4 minus with 2x times x equals to 196. So after we expand all the equations, you will get 2x squared plus 8x plus 4x plus 16 minus 2x squared equals to 196. After that, you will get 12x plus 16 equals to 186. So you bring the 16 to the right side, and you will get 12x equals to 180. So you bring the 12x to the right side, and you will get 180 over 12. And so the answer for the x is x equals to 15. So I can just apply the polynomial in my daily life.
With this ingredient of 1 cup of flour, 1/4 cup of sugar, 1/3 cup of milk, 2 eggs, and half teaspoon of vanilla essence, I could make 10 pieces of pancake. Since I'm gonna visit my cousin this afternoon, let me just do 20 pieces of pancakes for their family also.
I can assume to make a pancake is equal to 1 flour plus 1/4 sugar plus 1/3 milk plus 2 eggs plus 1/2 vanilla essence. Then I could change all ingredients variable A to E, and it will become 1A plus 1/4B plus 1/3C plus 2D. Since I want to double the recipe, I could multiply everything by 2. So the equation will become 2 times 1A plus 1/4B plus 1 plus 2D, and it will become 2A plus 1/2B plus 2C plus 2D and plus 1A.
Seems like I need to use 2 cup of flour, half cup of sugar, 2/3 cup of milk, 4 eggs, and 1 teaspoon of vanilla essence to make 20 pieces of pancakes. I don't know that I've been using polynomials in my daily life.
My mom just bought a dispenser containing a bottle of sanitizer that can be disposed completely. If I have the same 3 ideal little bottle and I fill each bottle with the sanitizer from the containing dispenser, how much capacity can be removed into each of the bottle, and how much the amount of sanitizer left in this dispenser?
Let's assume that this dispenser contains 2s power of 4 plus s power of 3 plus 5s plus 1 volume of sanitizer, and the bottle have s power of 2 plus 1 capacity. If I'm using the long division method from what I have been learning this morning, I could get the capacity that can be refilled into each of the bottles and how much the amount of sanitizer left in this dispenser. If 2s power of 4 plus s power of 3 plus 5s plus 1 divided by s power of 2 plus 1. So 2s power of 2 times s power of 2, and we will get 2s power of 4. Then 2s power of 2 times 1, we will get 2s power of 2 minus, and we will get s power of 3, negative 2x power of 2. Then x times by x power of 2, and we will get x power of 3. And then x times 1, and we will get x. So we will get negative 2x power of 2 plus 4x. And then negative 2 times x power of 2, and we will get negative 2x power of 2. Then negative 2 times 1, and we will get negative 2. Minus, and we will get the remainder is 4x plus 3. So we can assume that the capacity of each bottle is 2x power of 2 plus x minus 2. And the amount of sanitizer left in this dispenser is 4x plus 3.
It seems like what my lecturer says right. I need to apply the theory of what I have been learning to understand more what I have been learning.
This part of polynomials is kinda hard. I only know the type 3 of partial fraction. Why I need to study this partial fraction? I can't relate anything with my daily life.
You should not say it like that. Partial fraction is very useful for our learning. It can break the complicated fractions into sum of simple. It can be applied to integrating rational functions in calculus, and also help on differential equations that relate with their derivatives. Seems like you are in trouble, so let me help you with some examples.
3 types of partial fractions. For example, for partial fractions, type 1s are 2x express 2x plus 3 over x minus 1 times x plus 2 equal a over x minus 1 plus b over x plus 2 equal a over x minus 1 times x plus 2 plus b over x plus 2 times x minus 1. We get 2x plus 3 over x minus 1 times x plus 2 equal to a times x plus 2 plus b times x minus 1 over x minus 1 times x plus 2. We get 2x plus 3 equal a times x plus 2 plus b times x minus 1. We get 2 times 1 plus 3 equal a times 1 plus 2 plus b times 1 minus 1. We got a equal to 5 over 3. Then 2 times negative 2 plus 3 equal a times negative 2 plus 2 plus b times negative 2 minus 1 equal to b. Then we get b equal to 1 over 3. Let's see, 2x plus 3 over x minus 1 times x plus 2 equal to 5 over 3 times x minus 1 plus 1 over 3 x plus 2. Fractions type 2. Express 3x plus 1 over x power of 2 times x plus 1 equal to a over x plus b over x power of 2 plus c over x plus 1 equal a over x times x plus 1 plus b over x power of 2 times x plus 1 plus c over x plus 1 times x power of 2. 3x plus 1 over x power of 2 times x plus 1 equal to a times x plus 1 plus b times x plus 1 plus c times x power of 2 over x power of 2 times x plus 1. We get 3x plus 1 equal to a times x plus 1 plus b times x plus 1 plus c times x power of 2. Then let x equal to 0. 3 times 0 plus 1 equal a times 0 plus 1 plus b times 0 plus 1 times c 0 of power of 2. Then we get b equal to 1. Next, we let x equals to negative 1. 3 times negative 1 plus 1 equal to a negative 1 times negative 1 plus 1 plus b times negative 1 plus 1 plus c negative 1 power of 2. We get c equal to negative 2. Lastly, we let x equal 1. 3 times 1 plus 1 equal to a times 1 times 1 plus 1 times b times 1 plus 1 plus c 1 over 2 power of 2. We got 4 over 2a plus 2 times 1 plus negative 2. 2a equals to 4, and lastly we get a equals to 2. Therefore, 3x plus 1 over x power of 2 times x plus 1 equal to 2 over x plus 1 over x power of 2 equal to 2 over x plus 1.
The fractions of type 3 is 4x over x plus 1 times 3 plus x squared as partial fractions. 4x over x plus 1 times 3 plus x squared equal to a over x plus 1 times 3 plus x squared plus bx plus c over 3 plus x squared times x plus 1. 4x over x plus 1 times squared equal to a times 3 plus x squared plus bx plus c times x plus 1 over x plus 1 times 3 plus x squared. For x equal to a times 3 plus x squared plus bx plus c times x plus 1. Then we substitute x with negative 1, and it will become 4 times negative 1 equal to a times 3 minus 1 square plus b times negative 1 plus c times negative 1 plus 1, and it will become 4a equal to negative 4 and a equal to negative 1. Then we will substitute x with 0, and it will become 4 times 0 equal to negative 1 times 3 plus 0 square plus b times 0 plus c times 0 plus 1, and we will get the value of c, which is 3. Lastly, we will substitute x with 1 to find the value of b, and it will become 4 equal to negative 1 times 3 plus 1 square plus b times 1 plus 3 times 1 plus 1, and then b is equal to 1. Therefore, the equation will become 4x over x plus 1 times 3 plus x squared equal to negative 1 over x plus 1 plus 3 plus x plus 3 over 3 plus x squared.